show you how to do a repeated measures one-way ANOVA. So essentially here we've got 5 different footwear and participants have all used the 5 different footwear to perform an agility test. So it's the same people have done 5 different conditions. So we call this a one-way repeated one-way repeated measures ANOVA because you've got one variable you're measuring but 5 different conditions. So the first thing to do, we need to double check that our data is normally distributed. So we're going to go to descriptives. We're going to highlight all our variables, go across. Here we go. It's always good to see, as I said previously, to show that our means and standard deviations. But let's look at our Shapiro-Wilk test. So if we look at the p-value for each of the shoe conditions, you'll see that they're all above 0.05. So we can safely say they're all normally distributed. So we're meeting our parametric assumptions. So now we're going to go to ANOVA at the top, go to repeated measures ANOVA. And here we've got a slightly different view. So on the right hand side it says RM factor. That's our repeated measures factor. In this case it's going to be shoe. So obviously we've got 5 different shoes. Now we've got 5 different shoes, so we want to label the first one. I'm going to call it ASICS. The second one I'm going to call Adidas. Oops. Then we've got Nike, get a new factor. We've got Reebok, and then we've got Puma. Okay, so now we want to put them all in the repeated measures cell below. So we highlight them across. We want to do some descriptive statistics, so it's good to see the means and standard deviations again. We do need to check for equal variance, and we do this through this veracity test. So we want to look at Morchley's test, and if it's significant, then we should look at Greenhouse-Geyser results. So I've clicked Greenhouse-Geyser because I can see that the Morchley's test has come out as significant, so we have to do a Greenhouse-Geyser correction on our data. So if we look at the top here on the right hand side, we've got our repeated measures ANOVA. So we've got our shoe, and we're going to look at the Greenhouse-Geyser line, look at our p-value, and it's less than 0.05. So we can say there's a significant difference in agility sprint times between the different shoes. Our problem is we don't know if it's between ASICS and Adidas, Adidas and Nike, Nike and Reebok. You know, we don't know where that difference is. So what we need to do now is do some post hoc tests. So you see down here on the left hand side it says post hoc tests. So I'm going to highlight shoes and put it across. We like to use the Bonferroni correction. It's just, that's the best one when we're doing a one-way ANOVA. So if we scroll down on the right hand side, we can now see this post hoc test box. And what this is doing is it's looking at between ASICS and Adidas, is there a difference? And we look at our p-value at the end. Yes, there is a difference. If we go up to the descriptors slightly above, we've got ASICS, and we can see the mean is 32.992 and Adidas is 32.208. So we can now say that they're quicker when they wear Adidas in comparison to ASICS. If you go back to the post hoc test, you'll see ASICS versus Nike. The p-value is 1, so no difference. ASICS and Reebok, no difference. ASICS and Puma, no difference. So you just read the table like that and you work out where the difference is, but then you go back to your descriptives to understand what is that difference. Is one greater than the other or lesser than the other?